recording. So radar 1, radar 2, radar 3, and radar 4 we have. Perfect, right? Let me connect the cable. There we go. And let me start my devices. Okay, and because that should be 10.1, sorry, 12.1. 10.1, 12.0/24. This will be 12.2. This will be 23.2. This will be 10.1, 23.0/24. This should be, hello? सी 10 के पास आ रही है भैया? हाँ मैं आ रहा हूँ. Configure the sky. I want 34 large 0/24 and study code of it. So one thing, I have a loopback interface. I already explained what is the loopback. So I have a loopback 1.0.0/8. That's considered you can as a VLAN number 10. Loopback number 2 I have. It's 11.0.0/8. That's how the VLAN number 20. Okay, you just need to consider it. So I'm assuming like my loopbacks are treat like a LAN network. So 4 and 44. All right, so we have 10 and 20. And what is this now? Okay, this is the configuration of the SD-WAN. I need to set this guy SD-WAN skinny configuration. Now I'll be back. Just give me 2 minutes, guys. Okay, I'll be back. Hey, I'm so sorry, guys. So the courier guys, we lost somewhere. So I'm still waiting. Meantime, I'll do one thing. I'll just configure the IP addresses, right? Okay. Interface 0/0 IP address v10.1.12.1/24. And then we have interface loopback number 1. I can have a /8. You know, one thing you can give the description. I'll explain you that if you guys remember that. VLAN number 10. If you want. So that another engineer will come, he will get to know that, okay, there is this loop back is for the VLAN number 10. That's called the best practice, nothing else. It's not a mandatory. And then we have a route 2. Route 2, we have a interface 0/0 IP address v10.1.12.2/24. No shut interface 0/1 IP address will be okay 1/0. IP address v10.1.23.2/24. No shutdown. R3, we have interface config interface 0/0 IP address v10.1.23.3/24 and no shutdown. And here we go interface 1/0, that's 34.3/24, no shut interface R4. R4 we have a same thing config interface 0/0 IP address 10.1.34.4/24. And I have a few loopbacks. Again, loopback is what? It's a logical interface. Doesn't have a MAC address. And even it's a logical, so no need to give the no shutdown command over there. So here I'm not gonna give the description. Like just wanted to tell you, like it's not a mandatory, it's a best practice. Right? All done. So let me take a console. Okay. All good. So let's copy it R1. All done. The bad mask.
Unknown caller.
तो कल आप लेके आओ ना। You forget my career. So all done. So another one. Okay, I got somewhere there mass of the submit mask bad with that. There's a bad submit mask. I got it. I don't see anywhere. Do show IP interface brief. Interface loopback number 2 has a bad submit mask. Okay. Router 1 has done. Router 2 we have now. All good to go. Router 3. And router 4 we have. If you guys remember that, what we have done in the last class, so we have covered the like a dynamic routing protocol concept. Like we have seen that what is the difference between the static route and dynamic route. We have seen that like in a static route, what happened normally, you need to define those route which is not present in your routing table. In a dynamic routing, what happened, we need to advertise the directly connected route, right? So we have seen that we have different ways, protocols we have, like EIGRP protocol, IGRP, EIGRP, OSPF, ISS, BGP. These are the part of the dynamic routing protocols, right? And these protocols are categorized under the distance vector or linked state routing protocol. So we have seen that EIGRP is a part of the distance vector routing protocol and the advanced or linked state as well. That's why the EIGRP is called as a hybrid protocol. Why we call as a hybrid protocol? Because it has some feature of the linked state routing protocol. For example, your neighborship. Normally, the neighborship features is a part of the linked state routing protocol. It is not a part of the distance vector routing protocol. But EIGRP is leveraging the feature of the linked state routing protocol. That's why we call as a hybrid protocol. We have seen that how to configure the EIGRP and how to assign the router ID, right? So we have seen this configuration, if you guys remember that. On a router 1, we did the router EIGRP. And then after that, you can need to define the autonomous system number, right? So I can say that, okay, autonomous system will be 1 for the router number 1. And then I can call as a EIGRP router ID will be 1.1.1. That's a manual configuration, right? And then I said the network will be what? I said the 10.1.12.0, right? And then I can define the wildcard bits for this guy. So one thing is very important. There's a 2 ways to define the network statement in EIGRP. Like if you have a classful route means what? A classful route is known as a 10.0.0.0/8. That's called the classful route. 172.16.0.0/16, that's a classful route. 190.1.0/24, this is a classful, because these are not crossing the boundary. The subnet mask boundary, they are not crossing it. These are called the classful route. So if you have a classful route, you can simply say the router EIGRP number 1. And if you want to define the router ID, you can define it. It's not a mandatory. Otherwise, it will take the highest loop back. And if you don't have a highest loop back, then it will go for the physical interface IP address. So what I can say that I just simply say that, hey, network will be what? 10.0.0.0, network 170.16.0.0, and network what? Like this way. I can configure, there's no issue. But if you have a classless route, right? If you have a classless route, like for example, you have a 10.10.10.0/624, right? Actually, if you see, this is the part of the class A, but the boundary is the class subnet mask is a /24, right? This is called the classless route. Then we have a 172.16.1.0, right? /24 as well. This is also called the classless route. If I say the 192.1.0 or maybe the 1.0/27, this is also called the classless route, right? So what I can do that in this way, I can say the network what 10.10.10.0. Then you can define the something called as a wildcard mask. So wildcard mask is what? The wildcard mask is just a opposite of, right? It's the opposite of subnet mask. It's the opposite of subnet mask. So for example, your subnet mask is what? Your subnet mask is a 255.255.255.0, right? So the WC, the wildcard mask will be what? It will be 0.0.0 will be 255. So in a subnet mask, normally what we call, in a subnet mask, we call as a 1 is match it, right? And 0 means ignore it. That's a behavior of the subnet mask. In a wildcard mask, we are saying that, hey, 0 is match it and 1 means ignore it. So when I say the 10.1.1.0, understand the concept, I put the subnet mask is what? /24, 255.255.255.0. When I'm saying that, hey, match the first octet, that's 1 means what? Match. So if you add all the values, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, right? If you're going to add all this value, 1, 1, 1, 1, 1, 1, 1, that's something of match it, right? Then it will become the 255, right? Same thing, 255, 255. If I say the 255 match it, 255 match it, 255 match it, ignore the fourth octet. That's the meaning of subnet mask, because 1 means match. But when I say the wildcard mask, so the wildcard will be for this guy is what? I'm saying 0 means what? Match the first octet, match the second octet, match the third octet, and ignore the fourth octet. I don't care it. So wildcard is just the opposite of submit mask information. So if you have a submit mask like a 255.0 or 0 or 0 or 0, so wildcard will be what? It's a 0.255.255.255. If you have a 255.255.0 or 0, that's a class B submit mask information. The wildcard will be what? The wildcard will be 0.0.255.255. Understood? That's how you can calculate the information. What you can do that in a simple ways. For example, let me write on this thing in submit mask information, right? One is match it, 0 means ignore it. Okay, in WC wildcard, 1 means ignore it, 0 means match it. Wildcard mask is opposite of submit mask, right? Wildcard mask is opposite of submit mask information. Now, what you can see that over there in a wildcard, for example, if you have a submit mask is what? 255.255.255.0, then wildcard mask will be what? It will be 0.0.255. So take example, if you have another one, I'll call this guy as a /16, right? Then what it happen? It will be 255 over there. Same way, right? If you have a class C as well as, sorry, class A as well. For the class A, what you can do that? For example, I just have a 255.0.0, that's a class A submit masking function. So wildcard will be what? It will be 0.255.255.255. So it's just the opposite, just turn on the bit. Just flip the bit, that's all. So in a wildcard, we can call as a 0 is a match it, 1 is a ignore it. So when I say the classless route, if you have over there, in a EIGRP, if you have classless route, then you need to put the wildcard mask over there. Again, it's not a mandatory. It's a good way to configure the EIGRP for the classless route. If you see in the production network, people are not doing this thing. If you're not doing this thing, then what happened? You will see the problems in a configuration. You can still send the traffic from one end to the another end. There is no issue. But the configuration wise, right, troubleshoot wise, it will become the lengthy for the other engineers. So the best way to configure the classless route for the EIGRP, just do that in the wildcard mask. So if you see this is a /24, I need to tell this guy, hey, listen to me, this is the wildcard bits for this guy. I need to say the match it, class C, right? Class, if it's /24, we have 1 octet, 2nd octet, 3rd octet, and 4th octet, right? So what we can say that, hey, match this one, match this one, match this one, and the 4th is ignore it. Same thing if you have a different one, 176.16.1.0. Even I put this command, there is no issue. There is no issue. The command will be accepted. And now for the network, now we have what? 191.1.0. Now for this guy, what is the submit mask we have? /27, right? For the /27, how you can find it? So if you see for this guy, we have a /27. /27 is what? 24-bit will be on, right? First octet, 2nd octet, 3rd octet. 24-bit will be on. That's why 24-bit. In a 4th octet, what happened? We have first bit is on, 2nd bit is on, and 3rd bit is on. 20 plus 4, 3. We have 27. So what is the value for this guy? 128. What is the value for this guy? 64. And what is the value for this guy? 32. How much it will give? 224, right? So the subnet mask for this guy is what? It should be 20 and 20, 255.255.255.224 we have over here. What is the WC now? W mask, wildcard mask. The wildcard mask for this guy is 0.0.0. Now what you have to do that, you just need to minus from the 255. So if you're going to minus from the 255, right, what you will get that? 5 plus 5 is 1, 3. That's all. So you will get the wildcard mask is what? 31 for this guy. Just minus from the 255. Whatever the values you have, just minus from the 255 over there. Then you will get the wildcard mask for this guy. So the wildcard mask for this guy is what? 31. So the ways that you can figure the EIGRP is how you can configure in the two ways. Either you can call as this way, that's for the classless out, that's a good way. In a classless out, you can configure this way as well, or you can configure b dot wildcard mask as well. Both will be acceptable. So what I can show you right now, if you see, I'll see the router EIGRP and network 12.0, and I'll see the wildcard mask, right? And network, these are the class pulled out. So I don't need to define any wildcard for this guy. Router number 2, what I can do that now, I say the router EIGRP router ID will be what? It's 2.2.2.2. What I told you about the router ID. Router ID is just a name of the router, nothing else. So it doesn't mean that you need to have a same IP address on the router side. I said the network is what? 10.1.12.0. And now I'm not going to do anything, guys. I'm not going to define the wildcard mask. And as the network for this guy is that 10.1.23.0, define the wildcard. So both will be acceptable. R3 we have. Now router EIGRP router ID will be what? Now understand the 3.3.3.3. Now how many networks we have on router 3? We have two networks. This guy and this guy on the router 3, right? That's my directly connected network. What I can do that now? See the beauty of the wildcard mask. I can see that in a wildcard, what I told you that in a wildcard mask, the one is what? One is called as a ignore, and 0 is called a what? Match it, right? So in a single command, I will advertise both the dot. How? I'll say that 10 dot in a network. I say that 10 dot 1 dot. I'm going to match the both octet, right? And I say that 0.0.0. That's my network statement. That's my network part. And in the wildcard mask, what I can say that, hey, 0 means what? Match it. So match the first octet, that's 10, and both have a 10 right now. Match the second octet, both has a 1 and 1, and ignore the third octet. I don't care it. So based on the single command, what I can do that, I'll advertise the both the router. That's a beauty part of the wildcard mask we have. For the router 4 now we have, what we can do that? As the router EIGRP 1, here I'm not going to define the router ID. If I'm not going to define the router ID, then what happened? If you don't define the manual, it will go for the highest loopback. Which highest loopback I have right now? 44. So the 44 will become the router ID. And I can simply see that what? Network. I'll see that 10.1.34.0. And that's all. Network 4.0.0. This is the class code. No need to give the wildcard mask for this guy. All done. So if you go on the router number 1 and put this command, the command will be acceptable by the router 1. Router number 2 now we have. So right now what happened, router 1 is going to keep sending the hello packet. What I told you was that once you enable the interface into the EIGRP protocol by using the network statement, what happened? This interface will be enabled in the EIGRP protocol, and he will keep sending the EIGRP hello packet. So if you see debug EIGRP packet, you will see the hello is going on from this interface. I'll keep sending the hello packet to the router number 2, but router 2 is not responding it because router 2 has not been enabled in the EIGRP. If you see the show IP interface 0/0, this interface has joined the multicast group for the .10. That's used for the EIGRP, right? EIGRP multicast address. So let's configure on the router number 2 now. On the router number 2, what I can do that? I'll just copy this command line. Come on. All done. Now you can see that both the router has formed the neighborship. So he has sent the own hello packet to the router number 1, and he has sent the own hello packet to the router number 1. And once the router has exchanged the hello packet, if the criteria is matched, that's called as the neighborship criteria. If the criteria is matched, then they will form the neighborship. The first neighborship criteria we have between the router 1, right, is what? Key value should be matched. I'll explain you what is key value, don't worry about that. Second is what? We have a authentication what we match. So if you're gonna use the password, that should be matched. It's optional. If you are using it, that's fine. If you're not using, that's also fine. I'll let you know when should you use the authentication flow. But right now I'm not using any kind of authentication. That's also good okay right now. ACE number should be matched. ACE number should be matched in the sense of what? If router 1 is using the ACE number 1, router 2 also use the ACE number 1 over there. If somehow, right, if this guy is going to use the ACE number 2, they don't form the neighborship. Because what I told you that they will create their own logical domain for this guy, and they will create their own logical domain for this guy. So they will not exchange the hello packet over there. So router 1 will send the hello packet with the ACE number 1, and he will send the hello packet with the ACE number 2. They cannot understand it. So ACE number should be matched. Right? The fourth one that I have, they must be a part of the same subnet. Same subnet means what? If this interface is belong to the 2L.1 and this interface belong to the 2L.2, they will be a part of the same subnet. It doesn't mean that, like, for example, if I'm going to configure this guy's a 10.1.12L.1 this interface, and this guy's a 10.1.13.1. It means that this interface is the part of the 13.0 subnet. This interface is the part of the 12.0 subnet. They won't form the neighborship. So it should be a part of the same subnet. The fifth one we have, interface should be active. Active means what? If this interface is the active mode, active means what? This interface should be in the operational mode, right? This interface should also will be in the operational mode. Of course, that's an easy one, right? But take example, if this guy's operational mode, he keeps in the hello packet, and if this guy is not responding, they will not form the neighborship. Another one we have, interface should not be the passive. I'll explain you the meaning of this line. Hold on. You need to wait for the one more day for this guy. So whatever you know right now, that I'm explaining you. So you need to wait for the few things like a key values, this one. Right now, you know this part because I already explained you in the last class. So that's why I explained you. This part I will explain you. This part I explain you because you know these three things, right? This thing you need to wait for some time. So another one is what? The people are sometimes saying that the router ID must be different. It won't create any issues in the EIGRP neighborship. For example, if this guy's router ID is 1.1.1 and this guy's router ID 1.1.1, they will form the neighborship. There's no issue. It's a very beautiful question in the interview, guys. When you go with the higher level of the question, right? Higher level of the interview, they will ask you the scenario-based question. They will say that, hey, you know what happened? My EIGRP router ID is 1.1 and the another router is also a EIGRP router ID 1.1.1. Will they form the neighborship? What people are usually say that, no, they don't form the neighborship. They can form the neighborship, dude. There will be another issue comes in the picture, but neighborship will be formed. Okay, so router ID never comes in the criteria of the neighborship in a EIGRP, but we do have a criteria for the OSPF. So that's all we have. So if you see, they are all matching the neighborship criteria. That's why we are forming the neighborship. Same thing if you go on the router number 3 now. On the router 3, you can see that. I'll just configure this guy. With the help of single command, I'm just gonna configure both the interface. All done. And now order 4. So if you see what I explained you over here, if you just, I put the network 10.1.12.0 over there on the router number 2, I haven't defined the wildcard mask, but still I'm able to form the neighborship. So router 1 is forming the neighborship with the router number 2. Sorry, router 2 is forming the neighborship with the router number 1 and router 3. So all they are extending the hello packet right now. All they are extending the hello packet right now. There is no issue in the hello packet. So you can see on the router number 1 right now, if you see, so IP EIGRP, this is the first command, show IP EIGRP neighborship. This command will explain you, this command will show you the neighborship table that I told you that we have 3 major tables in EIGRP. One is called the interface table. Another is called the routing table, not interface table. One is a routing table. Second is called as a neighborship table. And third is called as a topology table. So right now we are seeing the neighbor table right now. So if you put the command show IP EIGRP neighbor, it will show you the neighbor information. So you can see that the first keyword we have over there, we have a AS number 1. The first line, if you see H means what? It's gonna represent you the handle. It's just gonna tell you the sequence number over there, how many neighbors you have. Always start from the 0. So if the router 1 will have a 2 neighborship, you will see the 0 and 1. And if you have a 3 neighborship, then you will see the 0, 1, 2. If you have 4 neighborship, it will show the 0, 1, 2, 3. Same thing if you see on the router number 2 right now, you will see the 2 neighborship. Because router 2 has a 2 neighborship. One is having with the router 1 and another is having with the router 3. So if you see handle is 0 and then 1 we have. Right? Then we have an address is what? So router 1 is saying that I'm present on the router number 1, guys, right now. So what router 1 is saying that, hey, I do have a neighborship with the 12R2. From which interface router 1 is forming the neighborship with the 12R2? This interface, my local interface, 0/0. Then after that, we have a hold second. It's a 12 right now. So what happened? We have a hello time is a EIGRP multicast service. Let me write on this thing. We have a 224.0.0.10 EIGRP tables. We have a neighbor table. You can see from the show EIGRP, show IP EIGRP neighbor, right? It contains the only neighbor information. Then we have a routing table, show IP root, or you can use this command as well, show IP root EIGRP, only for the EIGRP route. It contains the route table, route information, or we can call as a prefix information. Wait, guys. अच्छा कैसे की बात हो गई so it contains, right? So if you see the command for this guy, show IP EIGRP topology, right? So this guy is going to contain the information about the best route and second best route as well, if you have. Right? If you have. So if you see right now the show IP EIGRP table, if you see that we have neighbors and the timers that I was talking about. So EIGRP timers, if I talk about, so we have a hello time, that's a by default, it's a 5 second, and a hold on time, right? It's a by default 15 second. So the meaning of hold on time is what? So router 1 will keep sending the hello packet. Try to understand this language, right? So right now router 1 and router 2 has a form the neighborship, right? There's no issue with the neighborship right now. We have a EIGRP neighborship. So what router 1 will do that? He will keep sending the hello packet to router number 2. He will keep sending the hello packet to router number 1. Again, he will keep sending the hello packet to router number 2, and he will send the packet to the router number 1. Take example. What happened? There's some malfunction is happening on this side, on the router number 2, router number 1 side, this interface, right? Maybe there's the TX has failed, right? the transmitting ring, the transmitting has been, he cannot transmit any hello packet. Then what router 2 will do that? He will send the next hello packet, right? He will send the next hello packet, and he will send the next hello packet. So till 15 seconds, he will send the hello packet to the router number 1. 3 hello packet he will send. 5 second, 5 second, and 5 second, 15 second, right? So if I'm not getting the reply from the router number 1 within a 15 second, right? If the router number 2 is not getting the reply from the router number 1 within a 15 second, then what router 2 will say that, hey, you know, it looks like my neighbor is dead. I'm not getting any hello packet from my router number 1. The router 2 will consider he is dead right now, and he will remove the neighborship information from the table. So it will only wait for the 15 seconds. And after that, he will declare my neighbor is dead right now, and he will drop the neighborship with the router number 1. So that's the meaning of hold on time. Hold on time is just going to tell you how long I should wait before I'm going to declare my neighbor is dead. So why you are seeing the 12 right now? Because what happened? It's a start with a 15, then 14, then 30, and then 12, and then 11. When it comes to the 11, then what happened? Router 1 will send another hello packet. So he will restart the timer again. 15, 14, 13, 12, 11. Then router 1 again send the hello packet, or maybe router number 2 send the hello packet. Then it start with the 15 over there. So it's keep bouncing, it keeps shuffling between the 15 to the 11. Then we have uptime. Uptime is just going to tell you how long this neighborhood came up. SRT is always calculated in the millisecond. In a 1 second, you have 1000 millisecond. SRT stands for the smooth round trip time. A smooth round trip time is what? For example, we have router number 1 and we have router number 2. So if I'm sending something to the router number 1, router number 2, and if I'm getting the reply from the router number 2, the time interval between this sending and receiving is called as SRT. The time interval of sending and receiving is called as SRT. For example, if I'm sending you something and you are giving the reply back to me, right? So the time duration between the sending and getting the reply is called as SRT. RTO stands for retransmit out. Retransmit out means what? For example, if I'm sending you, then what happened? I'm not getting the reply. Then I will send another hello packet. If I'm sending you, I'm sending another packet to you. If I'm not getting the reply for that one. So that's called as the time interval of this guy is called as RTO. So these two things, right? This two timer is always calculated in the millisecond. Again, if you go in the very higher level details of troubleshoot, then this timer comes in the picture. As a CCNA and CCNP level, these things are so not important. You just need to know the basic things like what is the timers of this call. Queue count means what? How many packets are stuck in the queue? So normally you see right now the queue count is 0. So normally in this queue count, you only have a reliable packet. Reliable packet means what? I'll explain you the meaning of reliable packet. Don't worry about that. So we have two types of packet in EIGRP. One is called the reliable packet, another is called the unreliable packet. Then after that, we have a sequence number. So whatever the reliable packets we have, they have a sequence number. So sequence number just tell you, this column is just tell you what was the last reliable packet we have received from the router number 2. So these two things you will understand when I'm going to discuss about the packet types. Hold on just for the few minutes more, then I'll explain the packet type as well. So this is my first table we have over here, right? Second table, if you see my topology routing table, so IP route, you can see all the routes in my routing table. On the router number 1, you can see that I have a route of the 4.0.0, this route, and 44.0 as well. D4.dual, dual means EIGRP. At the same time, I have a 23.0 and 34.0 route as well, right? And if you see the SO IP EIGRP topology, I'll explain you this thing later, not now. Leave it this guy. Okay. So basically, we have 3 tables, right? EIGRP routing table, interface table, and neighbor table. Next part, what I want to show you over there, that's always network engineer loves. That you can see that I have a route in my routing table. So IP route EIGRP. I have all this route. So you can send the traffic. So if I send the ping 4.4.4.4.4, what I told you that by default, if you are not going to define the source over there, the exit interface will take the source, right? And if you're going to say the ping 4.4.4.4.4, I can define the source, I can say the 1.1.1. So in that case, what happened in the previous case, when I said the ping, so 12.1 was my source IP and the 4.4 was my destination IP. Now, when I say the source over there, 1.1.1. So source will be 1.1.1, destination will be 4.4.4. So we do have a end-to-end reachability right now. So there is no issue in the communication between this loopback one to this loopback. Right? Now, let's come to the packet now. So the packets we have in the EIGRP, as I told you, that EIGRP has a master type, or we can call as a packet types. Right? So basically, the majorly, right, if I talk about, we have a 5 types of packet in the EIGRP. The first packet we have is called as a hello packet. As you have seen now, just till now, in a hello packet, what happened? First of all, this packet is used to form the neighborship, right? This is not a reliable packet. This packet sent on multicast address 224.0.0.10. Another packets we have is what? Update packet. Update packet comes in the picture when the router advertise the router. When the router advertise the route, then update packet comes in the picture. What do you mean with update packet? Take example. We have router number 1. We have router number 2. We have a neighborship between this guy. And between this guy, we have a neighborship, right? So take example, what happened if the router 1 has a one loop back, which is the 1.0.0/8. So if the router 1 is said, hey, network 1.0.0.0.0, right? Then what happened? Router 1 is going to send the EIGRP update packet. So in this update packet, what happened? I will put the router information. This is reliable packet, right? And this will be sent on the multicast address, and we can call it an unicast too. So depend on the situation, it will go on the multicast and the unicast too. Then another type of packet, we have a QD packet, right? The QD packet comes in the picture when the router lose the network. Then this packet comes in the picture, right? This is again reliable packet. And this will go on the multicast address. And I think sometime once the something will fail, it will also go on the unicast as well. And then after that, we have a next packet we have is called as a reply packet. So reply packet only comes in the picture when you receive the query packet, then you have to send a reply packet. So reply only comes in the picture when you have a query packet. For example, if this network goes down, understood this concept right now on the router number 2, we have this information, right? 1.0.0 in the routing table, right? So what happens if I'm going to lose this network? So if I'm going to lose this network, then router 1 is going to send the QD packet to the router number 2 and saying that, hey, you know, one thing, I lose this information 1.0.0/8 in my from my network. So what you can do that, you also need to remove this route from the routing table. So what router 2 will do that, it will receive the QD packet, remove the route from the routing table, and it will give the reply packet too. And he will give the reply, hey, yeah, got it, thank you. So in a reply packet only comes in the picture when you have a QD packet. Okay, I am just giving you the overview of this packet right now. Okay, basic information. We'll be doing the deep dive of this packet on maybe on the Wednesday. Okay, so just basic understanding I'm giving you the packet right now so that you will have a clear picture. The next packet you have over there is called as acknowledgement packet. This packet is again reliable packet, right? And it will be unicast, not the multicast. Another packet we have is called as acknowledgement packet, right? Acknowledgement packet only comes in the picture. This is the receipt of reliable packet. So for example, whenever the router will send the whenever there are, and this packet is always a unicast packet. So whenever the router will send the reliable packet, right, the neighboring router will give the acknowledgement. For example, we have a 1.0.0.0/8 over there. This is the 10.1 and this is the 10.2. So take example, if the router 1 has sent the update packet to the router number 2. So update packet is what? It's a reliable packet, if you see. So what router 2 will do that? He will receive this router 1.0.0 in the routing table, and he will give the acknowledgement for this one. So acknowledge is what? It's just a receipt of reliable packet, and it always will be unicast. Again, take example, what happened now? If I'm going to lose this network, then what happened? Router 1 will send the QD packet. So when the router 1 will send the QD packet is what? It's a reliable packet. Router 2 first will give the acknowledgement. Okay, that's my acknowledgement packet. After that, because when I receive the QD packet, I need to give the reply back to you, right? So I will send the reply packet to you as well. After that, reply packet is also a reliable packet. Then what happened? Router 1 will give the acknowledgement for this guy as well. So whenever the reliable packet comes in the picture, you will have acknowledgement. Acknowledgement packet is not a reliable packet. It's a unreliable packet, not reliable. So if you see which are packets are not reliable, these packets are not reliable. So these two packets are not reliable packet. Apart from this thing, all packets are reliable. Okay, if you want, I can put this one in the notepad. So in reference, you can follow. EIGRP packet types. All good. Now understand the concept now. I'll explain you each packet, okay, individually. So we have a hello packet first of all, right? So if you see the hello packet, that router 1 is keep sending it. So what I do, whatever the interface which is enabled in the EIGRP will send the hello packet. So if you see the show IP EIGRP interface, these are the interface we have enabled in the EIGRP. This interface, loop back and loop back number 2. If you put the command debug EIGRP packets, what you can see that router 1 will send the hello packet. And if you capture this particular link, come on. If you see, so router 1 is keep sending and receiving the hello packet from the neighbor, right? So router 1, I'm receiving the hello packet from the neighbor and I'm sending it as well. You are. If you go and open the hello packet from the 12.1, what you can see that the source MAC is a CA01. That's a MAC address of this interface. If you just go on the router number 1 and have a look at the MAC address of this interface. So interface 0/0 include VIA CA01 2A54, right? The destination MAC is a 01005B00. This is the reserved MAC address for the multicast. Actually, if you see this MAC address, the 01005B, this 24 bits are always reserved. Okay. And the remaining 24 bit, it is copied from this multicast address. In reality, right? In reality, what happened? The 25 bits are reserved. In reality, I'm telling you. And 23 bits are not reserved. If you go in the higher level, when you go in the CCI level, then you will understand the concept of 25 bits and 23 bits. Total, we have a 48-bit MAC address, right? So just for the basic level, understand, we have a 24-bit is a reserve. Always you will see the 01005B for any multicast address. Any multicast address, if you go with the OSPF, if you go with the RIP protocol, if you go with the EIGRP, you will always see the 01005B. And remaining 24 bits, it's copied from the IP address. How it's copied? It has a universal rule of that one. So no need to learn that thing. Okay, that comes in the CCI part. Now after if you see that 12.1 is the source IP address and .10 is the multicast IP address. And now if you see EIGRP, we have a hello packet. So the reason we put the Cisco EIGRP because it's a proprietary of the Cisco. So we are using the version 2 and we have a hello packet. And then here we have an autonomous system number over here. Right? So if you're going to use the authentication, then you will see the authentication field over there. Right now, we don't have an authentication. That's why we are not using the authentication. That's why we don't see the authentication over here. Another part, if you see the sequence number, this field is going to tell you, hey, this is the reliable or not. So if you see the sequence number is 0, sequence number 0 means what? It's an unreliable packet, not a reliable packet. So in a hello packet, you will see the sequence number 0. Always. So that's my first packet of the EIGRP, right? Second packet, if you see, what you can do that for the second packet, I'll just generate the one route. I'll create the one loop back on the router number 1 so that it will send the update packet. I'll enable the debug EIGRP packets. I'll see the update, query, reply, acknowledgement. I don't want a hello packet because hello is it's a periodic packet. So I'll also enable same debug on the router number 2 so that I explain you the debug level as well. Okay, I'm not going into so much detail right now. The reason is that many things will be bounced. So I'm just giving you the basic things, right? Which is important according to the interview perspective, right? Because if I go with the each and every flags, because we have some flags over there, then many things will be bounced from there, right? There's things, flags over there. So many things will bounce. So no need to go the lots of level of the detail. Add for the NANP label. Yeah, it is required when you go with the I label, because in the normally in the CCI label, what happens? People have a different perspective and the requirement of the CCI person has a different label, right? Because whenever you sit in the interview and you say that you are the CCI, then they will ask you the question from the flags label. So, but NANP label, no need to necessary to read it because already you have a lots of things to read it. So now what I can do that I'll create the one loop back on the router number 1. I'll say the interface loop back number 4 or 100, I can call it. I'll say the IP address will be 100.100.100, right? Subnet mask /8. I'll say the network 100.0.0.0. What happened? Router 1 will send the EIGRP update packet. And what I told you that update packet is a reliable packet, right? So if you see, update comes in the picture, right? So router 1 has sent the update packet to the router number 2 on a multicast address, right? And if you see in this update, we are sending the route information. So if you see here, we have an internal route and another type of route, we have external route as well. So the default behavior is internal. When you say that network statement, the whatever the routes that you're going to advertise to the network statement, all they comes in the internal route. For the internal route, the AD value will be what? It's a 90. For the internal route, the AD value will be what? It's a 90. So we have a same information and this is the update packet. And if you see in this update packet, what happened? We have a sequence number because this is a reliable packet. So when I receive the acknowledgement from my neighbor, if you see that, if you see the 12.1 is in the update packet to the .10 multicast address, the 12.2, right, you can see is giving the acknowledgement, right? So if you see, this is the acknowledgement packet we have. And this acknowledgement packet is a totally a unicast packet. If you see, we have a acknowledgement number. So same sequence number I have sent, right, in the update packet, 7, and is giving the acknowledgement packet with the same sequence numbers. Sorry, same acknowledgement number 7. So maybe you have a question, hey, Law, I see the hello over there. So the header of the acknowledgement packet is similar to the hello packet. The header of the acknowledgement packet is similar to the hello packet. The how you can identify which one is a hello and which one is a, if you see, I'll open the any hello packet. How you will differentiate that, which one is the hello and which one is the acknowledgement packet. So the very basic difference what we have over here, if you see, both are what? Right? But the reason is that this one is a hello packet, because hello packet will go on the multicast address. In some scenario, hello could be unicast as well. Okay, that's a higher level scenario. Second thing is that how you can identify this is the hello packet. Hello packet doesn't have a acknowledgement number. That's a major importance step. Hello doesn't have acknowledged number, whereas acknowledged packet has a acknowledgement number. That's a major difference how you can initiate. So this is my actual acknowledgement packet, and this is my hello packet. So whenever you're sending the update, you will get the acknowledgement. So if you see the debug level now, have a look. So on the router number 1, I just create the one loopback. That's called as a loopback number 100. And I create the loopback IP address is a /8. So when the router number 1 is going to send the update on this interface 0/0, I'm sending the update. The length of this packet is 42 bytes. And what happened? I'm sending the update with the sequence number 7 over there. Can you see that? This field is going to tell you the acknowledgement number. This field is going to tell you the, so this header, this is the part of the acknowledgement. This is the part of the sequence. Sorry, this is the part of the sequence number. This is the part of the acknowledgement number. Okay, so once I send the update packet, I will receive the acknowledgement from my new. So if you see, here is the acknowledgement number. This is my sequence number. This is my acknowledgement number. Even if you check on the router number 2, I received the update. Okay, what is that? That has a sequence on 7. So I'm sending what? Acknowledgement to the 12.1. So that's how this 3 packet comes in the picture: hello, update, and acknowledgement. Update is a reliable packet. Now I'll have a look at the next packet we have. If I'm going to shut down this particular link 100, right, then what happened? I will send the QD packet. So if you see, let me pause this guy. So if you see, the QD comes in the picture, Control M. So router 1 is send the QD packet. In this QD packet, what happened? On the multicast address, this is the reliable packet we have because we have a sequence number. And here this route is down. Okay, so how you will get to know that this route is down? If you see in the normal update packet, if you have a look, this is my hello. If you see this is the update packet we have, right? And this is the QD packet we have. What is difference over here? The difference is in the QD and update, both have a routing information, right? Both are the routing information. Only the major part is what? The major part is what? The major part we have, if you see the QD packet, QD means what? The network is dropped, network is no more available. You have an infinity delay over there. But in this update packet, we have a normal values over there. These are called what? These are called as a metric we have over here. I'll explain you this thing. Don't worry about that. But just wanted to clear out this thing. Like a QD packet has an infinity value. Based on that, the router is removing the route from the routing table. The QD means what? This route is no more right now. I'm looking for something else. But update has a normal metric. This is the infinity metric we have. Right? So that's a 2 packets we have. Now the next 3 pack, the another packet we have after the QD, then what happened? I'll get the acknowledgement, of course. And then router 2 will send the reply packet to the router nodes. Can you see that? The 12.2 is sending the reply to the 12.1. So reply always will be a unicast packet. And this guy has a sequence number 8. So once the router number 2 will send the reply, then router number 1 again will send the acknowledgement, because reply is also my what? Reply is also my reliable packet. reliable, reliable, and reliable. So these three packets are reliable. So whenever you're sending these three packets, always you will see the acknowledgement packet. So in your neighbor table, right? So IP EIGRP neighbor. So I told you that now the Q count. So if you see the Q count, any number over there, 1 or 2 or something like that, it means that there is some issue with the neighborship. It means that there is some reliable packet has stuck in this queue. And this sequence number 16 is just gonna tell you which was the last packet you have received, right? So if you see this acknowledgement, I have received the reply that has a sequence number 16 over there. I'm going to put the sequence 16 over there. So what was the last reliable packet I have received? I'll just put the sequence number of this guy in the neighbor table. So if you see the router number 1, when I shut down this interface, then what happened? He's sending a QD packet. Hey, I lose this network. QD. What happened? The router 2 will give the acknowledgement because QD is the reliable packet. Okay, that's fine. Then after what happened? Router 2 also giving the reply. So he also giving the reply. So when I'm receiving the reply from the router number 2, what is my behavior? I need to send the acknowledgement. So if you're losing the one network, you will see the all these four packets in the picture. All good. So these are the 4 packet types we have in the 5 packets that we have in the EIGRP protocol. Apart from this thing, you also have a another type of packet like a SI query. We have SI reply. We have these things comes in the picture when I'm going to teach you the EIGRP stuff. So this is the advanced level of the features we have. When I'm going to teach you the EIGRP stuff, then these 2 packets comes in the picture. Now we are good to move to the topology table. So I told you that we have a topology table as well. So the topology table we have contains the 2 types of route, either the best route or second best route. Let me write on over here so that I can copy from this guy. So topology table, right, contains, let me write on this way, contains best route and second best route. If you have a second best route, right, then it comes in the picture. Take example. We have router number 1, we have router number 2, and we have router number 3, right? So take example, we have you are sitting on the router number 1, right, and you have run the EIGRP between router 1 and router 2, router 1 and router 3, right, and there is a network behind this guys 23.0. So in this case, what happened, router 2 is also going to send the 23.0 network to this guy, and he will also send the 23.0 network to this guy. Understand the concept. In this case, what happened, router 3 will put the matrix will be 10, and router 2 will put the matrix will be 5 over there. So what router 1 will do that in the topology table, right? In the topology table, he said that, okay, my best route is a 23.0, which has a matrix is 5 towards R2. And he will say the 23.0 I also have with the matrix 10 towards R3. So this is my topology table that you have, right? But what happened after running the dual algorithm on this topology table, the diffuse update algorithm that's EIGRP use, I will put this best route. I will put the best route into the routing table. So in the routing table, which route will come? It will come 23.0 with the matrix 5. Next hop will be router number 2. R3 will never comes in the because the matrix of this guy is what? 10. So lower matrix is always preferred. So if you have a backup path, right? If you have a redundancy, then you will see the backup path in the topology table. If you don't have, then you will not see that. The best route is known as what? The best route is known as a successor route. Successor route, it is known as a best route. So in a layman language, we can call as a best route, but in a technical way, the EIGRP give as a successor route. Successor means what? It's a preferable route. So successor route means what? Though have a lower metric to reach the destination. Then we have a feasible successor, right? It is a second best route, or we can simple and we can call as a backup route. Though have higher metric than successor. So can you tell me which one is a successor and which one is the not successor in this one? Anyone can tell me which one is a successor and which one is a feasible successor in this one?
Sir, 5 is sir successor route, sir.
5 will be the successor route and this one will be called as a feasible successor. So always remember one thing, successor route comes in the routing table. Feasible successor always present in the topology table. If successor goes down, then feasible successor becomes successor route. So take example, if this network goes down between router 1 and router 2, then what happened? This will be removed from my topology table. This will be also removed from my routing table. And then what happened? This guy will become the successor route. And if this guy will become the successor route, then what happened? This will be comes in the routing table 23.0, 10 will be metric, and the R3 will be the next one. If the successor goes down, again, if the successor comes up, take example, I'm so sorry. If the successor comes up, then what happened? Then the feasible successor will remove from the routing table. This will becomes in the again routing table, and this will also comes in the topology table. And this guy will become the feasible successor. And do you know how how long it will take to bring the successor and feasible successor? It will just take the convergence that I'm talking about right now, guys. It's very important. The convergence, it will happen just up to 1 second. Remember, if you guys remember that I told you the RSTP protocol or RPBST protocol, the spanning tree protocol. RSTP is doing the calculation within the millisecond, in the 800 millisecond, 900 millisecond, depend on the network type, right? Maybe the 1 second, I mean, sometimes it will take the 2 seconds. So PBST was slow protocol, right? Then we make a RSTP protocol in 2000 something. 2001 we made the RSTP protocol. So layer 2 was very faster. But what happened if you see the layer 3 is also faster protocol. The convergence, right? If this link goes down within a second, then what happened? This link will be converted into the primary one. That's the beauty of the feasible successor. Feasible successor is like a backup path. It will always there in the topology table. It will never comes in the routing table. Yeah, once you lose the successor route, then it becomes in the routing table. So if you see right now in my topology, do you see the feasible successor over there? No, I just have a single path. So always you will have a successor route. So if you check the topology table, so IP EIGRP topology, you always find the successor. To get this network, I have one successor, right? To get this network, I have one successor. To get this network, I'm on router number 1, guys, right now. I'm present on the router number 1. To get this network, I have one successor by the 1202. To get this network, I have one successor by the 1202. To get this network, I have one successor by the loopback number 1. To get this network, I have a one successor by 1202. To get this network, I have a one successor by loopback number 2. The meaning of P means what? It's a passive. The passive means good. The active means bad. I'll let you once you will learn the EIGRP stuff, then you will understand the meaning of this guy. Why the passive is good. Normally the passive is bad, right? And active is good. But in this topology table EIGRP, the passive is good. There is a reason behind it. Now, another type we have apart from the successor, the next thing we have two types of matrix. Matrix is basically what? Matrix is a integer number that helps the router to find the best path, or not find the best path, to select the best path. So matrix will be changed according to the routing table. According to the routing protocol on the table, right? For your information, static route does not use the matrix. Always you will see the 0 over there. Right? In EIGRP, if I talk about the EIGRP perspective, in EIGRP, the matrix calculation or matrix values are depend based on the interface properties. What are the interface properties we have? We have a bandwidth, we have a delay, we have a load, we have a reliability. These are the properties of the interface, guys. I'll show you that. Hold on. So MTU is stand for the maximum transmission unit. So if you go on the interface, any of the interface, right, do show interface 0/0, you can see the same values that we have. MTU is the by default 15 bytes, bandwidth is a 10 Mbps, delay is 100 microsecond, reliability is a 255, and load will be the transmitting load and the receiving load we have. So these values will be changed according to the interface. So if you go with the gig, you will have a different values. If you go with the serial link, you have a different values. So you don't need to remember these values. So these are the just properties of the interface. These things are called as a K values in EIGRP. So this guy in a EIGRP, they have defined the name. So in EIGRP, we call as a K1. We call as a load for the K2, right? We call as a K3 for the delay. These are the names that is defined by the EIGRP protocol. For the reliability, we call as a K4. And for the MTU, we call as a K5 over here. So these are just a key values. These are the names that EIGRP gives, all known as a key values. Right? By default, if I talk with the default behavior, by default, the bandwidth is used and delay is used for the matrix calculation. So you will see always over there, it's 1. It's 1. For this guy, you will see the 0 over there. So for the matrix calculation, right, only the bandwidth and delay is used. The reason is that there is a reason behind it, because these things are static in the nature. These are the static in the nature in the sense of what? When you buy a internet connectivity, then what you say that to the ISP? Hey, I need a 10 Mbps link. I need a 20 Mbps link. I need a this delay. I need a that delay. You're not saying that I need a that load and the reliability anytime, right? So the load and reliability, they are the dynamic in the nature. MTU we are not using for the matrix calculation, not used for matrix calculation. So the matrix that you see, whatever the matrix, if you go on the router number 1, show IP route EIGRP, you can see that we have some matrix for this guy, we have some matrix for this guy, we have some matrix for different matrix we have. This things is calculated, right? These values are calculated based on the bandwidth and delay, because by default we are using the K1 and K3. These two values we are using it. So if you put the command show IP protocols, you have a K1, that's a bandwidth, and K3, that's a delay. So if you see that, I have also mentioned over here, the K value should be matched in the neighborship criteria. So take example, if the router number 1 and router number 2, if they have a AS number 1, they have a AS number 1, both are the part of the same subnet. There's no any passive and active scenario. Everything is correct. But somehow what happened, if I'm going to configure this guy, the K1 is a 1 and K3 is also a 1, that's when the bandwidth and delay. But over here, if I change this guys, the K1 should be 0. Take example, it means that bandwidth I'm not going to use. I'm going to use the K3. That's a delay only. Then what happened? There will be a mismatch of what? K values. So if you have a mismatch of the K value, the neighborship will be dropped. So the K value should be same, right? Anyways, the default behavior is a K1 and K3. So there will be no issue. But if the network engineers change the K value, then you will lose the neighborship. If you're using the K1 is equal to 0 and K3 is equal to 1, then also you have to use the same value from this side as well. Then they will form the neighborship. But it is never ever recommendation to change the K value. Yeah, in some scenario, it is they will reach recommendation to change the value. If you go with the CCI lab exam, there will be some scenario based questions, right? So for that scenario to match that particular criteria, you need to change the K values, right? So what I'm talking about, so these are the matrix. So we have two types of matrix in EIGRP, right? One is called as a FD, is known as a feasible distance, right? And one is called as a RD, or we can call as AD, reported distance, or we can call as an advertised distance. A very simple way I'll explain you this two terminology. Let me write on first in the notepad so that you can have a notes of this thing. So by default, we EIGRP does use K1, that's for the bandwidth, and K3, that's for the delay, right? So we have a K1 is equal to bandwidth, and 1. That's always should be 1. K2 we have, that's called as a load. So these are the sequence we have. So in an interview, they will ask you the sequence order. Like a first is a bandwidth, K2 is a load. These are the sequence we have over here. So normally when you just say that, okay, bandwidth, reliability, MTU, so they will interrupt you in between and say, hey, can you please give me the answer in the sequence order? K4 we have reliability is also 0, and K5 we have is called as MTU, maximum transmission unit. So we are not using this thing for the matrix calculation. So by default, we are only using the K1 and K3. The reason to use the K1 and K3, I just told you that because these are the static in the nature, right? Two types of matrix we have, so, right? One is called as a FD, feasible distance. So feasible distance is called as a total matrix to reach the destination. Then we have AD, or we can call as a RD, right? Advertised distance, or we can call as a reported distance, right? This is called the matrix from my neighbor to the destination. What do you mean by neighbor to the destination? Take example. We have router number 1, we have router number 2, we have router number 3, and we have router number 4. So there's a network behind this guy, the 4.0.0.0.0, right? So what I'm assuming that the link between the data 1 and data 2 that the matrix is 10. The link between data 2 and data 3 is the matrix is 5. The link between data 3 to data 4 is the matrix is 20. And the link, the loopback link also has a matrix because this also has a bandwidth, reliabilities, right? Delay, load, MTU. If you see, loopbacks also has a, so this is the interface 0/0 properties. Loopback also has. So if you see, the interface 0/0 has a different one. Loopback also will be have a different one. So this will be changed depend on the media type. You see that? Loopback has a 15-14 bytes, MTU, bandwidth, delay, reliability, and text log. So they have a different, so this value will be changed depending on the media. So if you're going to use the gig Ethernet, serial link, so they have a different values. Tunnel has a different values. So even the logical interface has a different values over there. Again, no need to remember this thing. These are already present on the other side. So understand the concept. I said this loopback has a matrix, maybe the 2. So what's FD is saying that the total matrix to reach the destination. So take example, if you're sitting on the router number 1, so from the router number 1, the FD will be what? Total distance 10, 5, 15 plus 20, 35 plus 2, 37. Advertise, the name is saying advertise distance, means someone is going to advertise to me or report it, someone is going to report to me. So you are sitting on the router number 1, who is going to report to you? Of course, router number 2 is going to report to you. Router number 2 is going to advertise to you. So different books have given the different name. Some books is giving the RD and some books is giving the AD over there. So router number 2 is going to advertise the matrix 5 plus 20 plus 25 plus 2, 27. So router number 2 will say that, hey, listen, from the matrix is 27. So this 27 will become the RD or AD in your R1 topology table. Again, this